This time, you see, in the last problem we dropped a ball from a certain height. In this one, we throw a ball vertically up with an initial velocity of 25 meters per second. If it has a constant acceleration of negative 9.8 meters per second squared, how long does it take to reach the maximum height? What is the maximum height? Okay, this time you are at the origin. Your initial position is 0. Y0 is 0. But you have an initial velocity. You stand at the origin and throw the ball up with a certain velocity. What is that velocity? 25 meters per second. All right, let's put this down. The ball is at y equal to 0, at t equal to 0. You are standing at the origin and ready to throw the ball up. That means at t equal to 0, the ball is at y equal to 0. So we have y0 equal to 0. Position y at time t equal to 0 is 0. And also we know we threw the ball with this velocity. That means when you start the clock at t equal to 0, the ball has a velocity. That's the only way you can actually throw something up. You got to give it an initial velocity. So v0 is 25 meters per second. That's right, this ball is given an upward velocity. So, as usual, we take the acceleration, integrate it to find the velocity function. V of t equal to integral a of t dt. A of t is negative 9.8. So we got integral negative 9.8 dt will be negative 9.8 t plus c. There you go. And now we need to find the c1. How do you find c1? c1 can be found using this condition. When t equal to 0, when you replace this t by 0, then your v will be 25. So when this term becomes 0, the value of v will be 25. That's right. So we have 25 equal to 0 plus c1. That gives you c1 equal to 25. Therefore, what is our velocity function? V of t, therefore, is negative 9.8 t plus, in place of c1, we now write 25. That's our velocity function. Now, if you integrate the velocity function, you can get the position function. All right? Well, before we do that, in this question, we need to find how long does it take to reach the maximum height. Now tell me, if you throw a ball up with a certain velocity, say up with a certain velocity, can you see it? Now when it reaches the maximum height, it stops. So what is the velocity when the ball reaches the maximum height? At the maximum height, its velocity is 0. It goes up and stops and then returns. Is that right? So, we say when the ball reaches its maximum height, its velocity v equal to 0. So what we can do is, we can go to the velocity function and put the velocity equal to 0 and solve for t. It will give you the time taken by the ball to reach the maximum height. Is that right? Yes. What is the time taken for the velocity to become 0? The time taken for the velocity to become 0 is the time taken by the ball to reach the maximum height. That's right. Okay. So, we would say 0 equal to negative 9.8 t plus 25. And solve for t from there, t equal to 2.55 seconds. It means in 2.55 seconds, the velocity, see, as you throw it up, the velocity initially is 25 meters per second. The velocity will decrease, 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 become 0 there. And the time taken for that is 2.55 seconds. And then we also need to find what is the maximum height. In other words, what is the position y when t equal to 2.55 seconds? That is the question. So, we now have the velocity function. We have the time taken by the ball to reach the maximum height is 2.55 seconds. By using the velocity function, we can obtain the position function. How? Integrate the velocity function. Y of t is integral v of t dt, and v of t dt is negative 9.8t plus 25. So we replace v of t by this. That will be integral negative 9.8t plus 25 dt. Now here we need to integrate each term, right? Now integrating the first term gives you negative 9.8 t squared over 2 plus integral of 25 dt is 25t plus c2. And negative 9.8 divided by 2 is negative 4.9. So your position function is negative 4.9 t squared plus 25t plus c2. Well, in order that this position function may be useful to us, we need to know what that constant value c is. Okay, so what do you do that? We can do that from this condition. We know that when this t equal to 0, where is the object? The object, the ball, is at the origin. So y0 equal to 0. When you replace t in the equation by 0, y will be equal to 0. That will be 0 equal to, watch my pointer, this y becomes 0 when t in the equation becomes 0. That means this will become 0, that will become 0. That means what is the value of c2? c2 is 0. Therefore, what is our position function? Our position function, therefore, is y of t equal to negative 4.9 t squared plus 25t plus c2. Oh, well, c2 is 0, so this is not there. All right, just cut it off. Our position function is y of t is negative 4.9 t squared plus 25t. And now, once you know the position function, what we need to find is what is the maximum height. What does that mean? It means what is the value of y when the ball is at the maximum height. You know that the time taken by the ball to reach the maximum height is 2.55 seconds. So what all we need to do is find y of 2.55 seconds. What is the value of y at this time? Maximum height is y of 2.55, and that will be negative 4.9 t squared plus negative 4.9 times 2.55 squared plus 25 times 2.55. There I have done it for you. So y of 2.55 is negative 4.9 t squared, that is 2.55 squared, plus 25 times 2.5, plus, of course, c2 is 0. We have shown that c2 is 0. So that will be 31.9 meter. All right, try and do this problem on your own one more time.